Hello, and welcome to a new series where I will be making a Java game. Um, I'm going to first give you the code essentially, or run you through the code um, of like like the base stuff that you need for every game. So this is code that I will reuse every single time. Um, I might even probably turn it into a library because I use it so much. It's like just code that you need to write every single time um, to have a running game, and then you can start making your own stuff on top of that with classes and whatnot. Um, so make a new project. We can just do why not? Um, and you can do this in Eclipse, whatever. I'll just be using Java Swing. Um, it's built into Java. It's like relatively old. Even here at the bottom, you can see Swing UI Designer. We don't need that though. You can get a bunch of help online. There's a bunch of help. There's a bunch of resources online that you can get with this kind of stuff. But the way or the analogy kind of used for this is like imagine you have some kind of picture and you first have the frame, like the wooden frame around it. And inside of that wooden frame, you have your canvas. And then on that canvas, you can paint. And it's exactly what we're going to be doing. We're going to make a frame, which is essentially our window, add a panel to it, which is our canvas. And by the way, frame is like the actual name of the component. It's called JFrame. So our JFrame is our frame, and then we have a JPanel that goes on our frame, and we can draw on that JPanel. So with the main class, we're just going to have a few lines of code here. So we're going to start with a JFrame. Is equal to new JFrame, and it automatically imports for me. But if it doesn't, javax.swing with a little star, or you can do JFrame. Either one works. And I already added double quotes in here, but you don't need to. But this is where you can set the name for your game. So I'll call this basic game. And then to actually make the screen show up, because if you were to run it right now, nothing will show up, and the program will terminate. You can just go on frame dot set visible. This is like you want this to be the very last. You want the set visible to be the last method that you call, so put it at the bottom. And here at the very top right, you can see a little window up here. There you go. 2 lines of code. You already have a window. So this is our frame, and we need to add a JPanel on it. However, we want to customize that JPanel, and we're essentially going to add methods to that JPanel by using class inheritance, or rather using extends. So let's add a few things, starting with number 1, the basic size for the frame. So frame.setSize. And I'll show you why later. I'll just comment this out right here. So this size here, it says 800 by 800. So when I run the game, it will have what you think is an 800 by 800 screen. However, it is 800 by 800 from the top left corner of the window to the bottom right corner. And that includes the border. However, we are only able to paint on the white kind of part of it. And so it is actually off by 20 pixels on the X and 30 pixels on the Y or something like that. And we will fix that later. But right now, this is like if you don't really care too much about the size and it's not like perfect. But a lot of your calculations, especially if you're making like a chess game, for example, oof, it's really annoying because if you want every single one to be, let's say, 100 by 100, it's going to be off on the two rows, or the row and column. But yeah, leave that there. Otherwise, we're going to have frame.set resizable to false. So I don't really want to resize my game. I like it how it is. These are all just kind of like to your own discussion. This one's kind of helpful. Exit on close. That just means like right now you can see here in my taskbar I have nothing, no icon for my game. However, my program is still running. So if I rerun it now, you can see a little icon there. And before, when I click the X, the game would continue running. But now when I close it, it terminates the program. And then finally, frame.set location relative to null. And this will essentially make the window appear in the middle of my screen. And it's really, really useful because up here, no, not a big fan of it. But these are the 4 commands that I kind of like to have at the very bottom. And now we can add our game panel. Call this game panel. And like we said, it will extend JPanel. So it will inherit all the stuff from JPanel. And we're going to add methods to it as well. And we're going to have our game run on a new thread because we don't want it clogging up the main thread because there are other stuff going on in the main thread. So we are going to make a new thread by doing implements runnable. There you go. And it has one method called run. And we'll work on that in a second. However, we're going to start off with a constructor. This constructor won't do anything for now, actually. But we'll start off by making a thread. We just said we're going to make a thread, so let's make it. Let's have a method called start game thread. And here we do game thread is equal to new thread. And that's in this. And the reason we have runnable is because if we did not have it, this would cause an error. And so we need runnable. It just helps us make a new thread. So this entire everything inside the run, it will keep on looping. So if we have like a while true loop in here, or whatever, this will keep on running forever on a new thread. That's exactly what we're going to do. Then we can go game thread dot start. That will start the game thread. And we can just add that method down here after we make the game panel. Okay. And then game panel dot start game thread. Sounds pretty good. Let's start off by talking about the size. Actually, let's first do the fill in the run method. So we're going to do a bit of math here, but we're going to have our FPS. And we do that, by the way, this underscore here, it's just help for visualization. It doesn't actually add anything to the number. You can take that out. It doesn't do anything. Same number. And then we're going to have, you just make sure it's 1 billion. And make sure it's a double as well. So 1 billion double. You can probably just do like 1E9. Same thing, actually. This just means 1 billion as a double. And then divide by 120. And we're going to have our double delta. Then we're going to have our previous time. And we're using 1 billion because of the nano time. Because 1 nanosecond is 1 billionth of a second. Then we're going to have a last check. This will be for counting our frames, like how many frames per second we're running, just to make sure that this is accurate. Our math is working out. And we can have a while true loop, and we can just say while game thread is not equal to null. It's basically a while true loop. I don't know. If something goes on with the thread, it won't cause an error. It'll just stop the while loop. So a bit more safer. So we get the current time. And then add to our delta the difference between the times divided by our FPS. And make sure you set previous time to current time. And then we check if delta is greater than or equal to 1. Then we can update. We can repaint our canvas. We can subtract 1 from delta, and we can add 1 to frames. And repaint is not throwing an error because it's an actual method that will repaint the game. However, update is something we actually need to implement. So public void update. This is all our logic, game logic going on in here. And then we need to override a method from gamepanel or jpanel called public void paint component. Takes in graphics G. You'll be wondering, we can actually call this method because we can't make a graphics G like object. If you were to make one, graphics, look at all those methods. Look at our file. It's huge now. So we will not be doing that. But we can actually make it. So Java will make the graphics G object for us, and we are able to use it. And by calling repaint, we are essentially calling this method without having the need of making a new graphics G. It'll just reuse the old one that Java made for us. So in here, we can actually just make a rectangle here, g.fillRect. This is where you're going to be drawing all your stuff. So if you're trying to make a chessboard, or you're trying to draw some images onto your screen, you do that here. I'll show you how to make some images as well. But this is like, oh yeah, also here, continuing on. If system.current time millis minus the last check is going to equal to 1000, that means that 1 second has passed. Then we can print out our FPS as our frames. You can make the last check equal to the system.current time millis, and then we can make frames equal to 0. We can go ahead and draw a rect. And everything works out. I can already see the error. We need to add the add game panel. Okay. See how that goes. And boom, everything's working perfectly. We have a rectangle drawn here, or rather a square. And we have our FPS at 120. That means it is refreshing 120 times per second. Also, if you want to fill in the rectangle, because right now it's just an outline, replace the draw with fill. And if you want to change the color, you can do g.set color. Play around with these methods. You can see a lot here, a lot of different stuff. Not super overwhelming. Everything just kind of is exactly what you expect it to be. If you want to draw text, for example, like or g.draw string. You can have your message in here, so hello world, and set the location. Let's do it like 200. Now you will notice that that doesn't seem like enough. Like, where's the width and height? You can't actually do any of that. So when I run it here, it will have a basic thing. It'll be pretty small, default. And then you can see our rectangle is now filled in. The way to change like the font and all that is by doing g.setFont. And you create a new font of some name. So you can do Calibri. And then have like some kind of thing like this, bold, plain. You can just do plain, why not? And then some size. You can make like 100 to make it really big. And this is like relative to like Google Docs or something size. 100, pretty big, right? You can play around with that. Set color, or you can just do color. Has a few basic colors like black, red, cyan, all that stuff. Let's go with magenta. But if you want to make your own color, you can just do new color and then have your RGB values in there. That's an eyesore. And let's do one last thing. g.fillRect at 700, 700, and it's 100 by 100. So we have our frame at 800 by 800, and now we're setting it in the bottom right corner. And here, like I said before, this is not the actual size. And you can see here, this is not a square. It's not 100 by 100. Doesn't look like it. And why is that? Well, like I said before, 800 by 800 goes from the top left of the window to the bottom right of the window. However, we want the size, or the size of our screen to be from the top left corner of the canvas to the bottom right, or like going down from there. And the way we do that is by going in here. We can make our own little method here. Also, these two methods here, you want to keep at the very top, right below run, relative probably, because they're the most important. And add any supporting methods below. Set game size. You can have an int width, an int height. You create dimension D. And then we can do this dot set minimum size to width and height, or to D, sorry, actually. This dot set preferred size to D, and this dot set maximum size to D. And then we can call set game size in here, and we need some kind of width and height, so we can take in a screen width, because it's certainly the screen, it's not the window height, so we can call it that. Screen height. And we're also going to make some variables so we can use later if like our game is like some components are relative to our width or height. We can use the variables here. And we can do this dot screen width is equal to screen width, and this dot screen height is equal to screen height. And then here we can remove this and put 800 by 800 here. And here we have another error. Our window is very tiny. And the reason why it's really tiny is because we forgot to call a method called pack, frame.pack. Pack is a method that will essentially adjust the frame size to include all the different components. So our component now is 800 by 800. That means our frame will accommodate to that, and it will set the size to be 800 by 800 plus the borders of the window. And so now you can see that this is an actual square now, and we have our game, and you can make whatever you want with it. I'll talk about input in 1 second, but just to kind of go over all the code that we made, we have a new JFrame. This is our window. Then we have a new panel, which is our canvas. We add the canvas to our frame. We make sure that the frame size is relative or includes what the canvas size is. We make it non-resizable, make the program terminate when we close the window, make it essentially appear in the middle instead of the top left, set it to so we can actually see it, so set it to visible, and then we start the game thread. Inside of gamepanel, we create a new gamepanel class that inherits all the jpanel methods, and it also implements runnable, so we're able to make a new thread, and that new thread will run this method, and in that method it will have an infinite loop here. And the reason why the program won't be stuck in this loop is because it's in a new thread. So it's essentially going to run this. So it's going to run this, but we are able to do something else. So we can, like, after we start the game thread, we can print out hello, and it'll still be fine because in the eyes of the main thread, all it's doing is creating a new thread, and that's one call, and that's all it's doing. It's essentially creating a new thread, running all this stuff constantly because we have an infinite loop here, and it's going to keep on running. However, our main thread will just continue on normally, and it won't be stuck in anything. Just see how that looks. We have hello, and so that means that our thread is like not clogging up our main thread. And threads are just kind of like how the code runs. So here you have a main thread. Imagine it just goes line by line, reading the code and saving any variables, right? But once it gets the game panel here, it's going to go to here, and it's going to start a new thread down here. And on that new kind of branch of reading our code, it's going to run this method. And that method is going to be run on the separate branch. We do a little bit of advanced Java here, where you're able to set the variable and use it in a single line. This saves like 2 lines of code. Kind of useful in the whole scheme of things, but then we use update. This is where our game logic is going to be. So something that is relative to time. So let's say you have a clock in the game. If you want to update the clock every second, then you can do that here by just doing like clock time +1 or something. Then we have our paint component. By the way, these are 2 major methods that we'll be using the entire time. For example, you'll never catch me actually calling g.fillRect inside of paint component. I'm going to make a whole new method, and essentially it's going to be public void draw square. It's going to take in graphics G, and we can just put that in here and call draw square colon G. And this will do the exact same thing that we just did. However, it will clean up our code. And it'll be really nice because we don't actually have any calls for G, and it'll be really simple and easy to track, and our methods will hopefully say, or they'll be named exactly what they're called. Then we set the game size inside of the game panel. So we set the canvas itself, the canvas's size with the width and height. And this is just making the thread. The code inside here, it's a bit of math. Just by looking at it, you can looking at it for a long time, you can kind of just understand what it does. But each time, it will add to delta, and it will add a very small fraction. And essentially, it's like a delta is kind of like a percentage. And when you divide it by FPS, this is like a percent. So once you have once a certain amount of time has passed, then you're able to actually repaint and update. This, if you'll notice, when you call this time, the current time millis, and this one, these are two different times. Oh. So these are two different times, so you're actually missing out on time here. But yeah. Now we can talk about input. For example, how to get user input, so our keyboard or mouse. We can do that. We can make a new class called just input. And this it won't inherit anything, but it will implement a few things. We'll do key listener as well as mouse listener. Implement all those methods, a lot of them actually. They're actually what they say. Key typed, don't really worry about that. You mainly want to look at key pressed and key released. So I'm just going to move these to the top here because they're more important. Mouse clicked, unimportant, but mouse pressed and released is important. Entered and exited, don't even know what that it does. Put that right below here. But for example, we're going to have some booleans. Up, down, left, right. So we're going to have a square that we're going to draw, and we're going to move it based on so we're going to have up, down, left, right to control our square movement. So we're going to move it by some amount, and we'll talk about how that works. So in key pressed, we're going to check if e.getKeyCode, which is a number, and inside key event they have some vk underscore, and then they have some constant variables which are integers that is used with key code. So we can say w, for example, and that's going to be, we're going to set up to true. So when we press W, that means when our key is pressed down, we want to set up to true. And we can do this 4 times. W, A, S, and D. This is left, down, and right. Copy this all over down to here and just set this to false, because when we release it, we want it to stop moving. And then in our update component, or update method, sorry, we're going to check if, actually we need to have an input, like an input class or input object. Input. And we're going to get it from here. Input. And this dot input is equal to input. The reason why we make it in main first, new input, and we can just place it in there, is because we actually need to also add it into here. So just above the pack, I like to put it, but just below the game panel, just do frame dot add key listener do input, because here we implement key listener, so you're able to do that. And update, we can do if input dot up. Then we're gonna actually have some variables, our player x and y. So player x and player y. Actually, we need to set them to something, so just set it to 0. Why not? And by the way, when you draw something, it will depend on the top left corner. So at 0, 0, when these two numbers are 0, that's not the middle of the square, that's the top left of the square. So yeah, we're gonna make player y, add, and we're gonna have another variable called speed. It's equal to 5. Yeah, so we just make a speed variable there, and you can set it to something lower, like 5. It's dependent on the pixels, so it's gonna move 5 pixels every time it updates. So if we're running 120 frames per second, that means it's gonna do 500 or 5 times 120, which is about 600 pixels. So in a total of 1 second, it can move 600 pixels. And then we can do this for every single one 4 times. So up, left, down, right. You can do up, down, left, right. Doesn't matter. This would be subtracting x. Down would be subtracting y. And yeah, one thing to note is look at the up and down, and I'm going to explain why it's actually wrong. And I think I'm missing something. Yeah. Also, we have to, when we draw it, you have to set this to p.x, or sorry, px and py. And I think we're missing one method. Okay. Never mind. I don't know why it works. However, just you need to have a method called request focus in here, because sometimes it won't actually let you focus in. I don't know, it's kind of weird. But from my perspective, I'm pressing W right now, and it's going down, and then S will make it go up. So it's actually going the opposite way. And the reason why is because normally we are used to our X and Y axis, and then to the right is the positive X, and then up is positive Y. The way this works is you have your X and Y 0, 0 starting in the top left corner, and then your positive X is to the right, and your positive Y is down. And whenever we set some kind of window size, it's going to start in the top left-hand corner here, and it's going to spread out from there. And that's why it kind of starts in the top left-hand corner. So just your Y's are going to be inverted, pretty much. Simple fix. It is kind of annoying, but you get used to it. So now you're able to move the square around. And this is kind of like the boilerplate code. This is going to be your like player or whatever. If you were to get to like some kind of game where you want to move the background instead, you would probably have the player stationary, or you would have some like bigger map, and then you would have your player move around with WSD in the background. But then when you actually draw your player, it's going to be in the middle, and you're just going to draw the environment around it. But I mean, you can use like a whole lot of stuff. You can implement gravity so that it's constantly going down. A lot of ideas you can do here, but yeah, there you go. You have moving square. But this is like pretty much the code. I'll show you a game that I made, a Flappy Bird remake, and look at my main method. Pretty much exactly what we just did. We have our frame, we have our input, game panel, we add, or this is like something that we don't have, but we're adding the game panel to input. But we're adding frame, we're adding input. That's mouse listener and key listener. We can use mouse listener just for our mouse, like clicking and whatnot. We set pack, an icon image. So when we actually run the game, like our image in the bottom, that'll be something we can talk about that. Why not? Resizable, location relative to, default close operation, set visible. Everything is familiar. We know exactly what it is. In game panel, we have a run method here. You can see it's pretty much identical to what we just did, with a few extra stuff like update. We don't really need to worry about that. It doesn't do a whole lot, but pretty much everything is exactly what we just did, and nothing really changes in here. You can see our update method right here and our paint component, with a lot of calls. G2 is just something that lets us do a little bit more, but we don't really need to worry about that. G is perfectly fine to use. And this guy here is how you implement images, and we'll get to that right now. So we're gonna actually make a new image right here. We can just put it in game panel, why not? And this will be our character image. So we're gonna use a buffered image. BI, why not? Is equal to, and what you want to do is do image.io. Actually, let's save it. Just make the like the object for now, and in here we need to a try and catch, an IO exception. Ignored. And we're going to do the BI is equal to image.io dot read, and we're going to do get class dot get resource as stream, with that. And it's going to highlight it with replace with objects dot required, not null. This isn't required. You can put it in, why not? But I don't know. Too much in one line. So in these double quotes, you're going to have your path to your image. So your image is going to be somewhere in your source folder. So let me go quickly get an image. If you have your desired image, I have a PNG right here of just the car. Put that in your source. Usually you're going to have like a new package, and it's going to be called res. And you're going to put all your PNGs inside there because it takes too much space. You can probably have like hundreds here or something. I don't know. This is just a normal car. If we, I don't know how to take out the background. But yeah, just a car, whatever. And we can put in the path. So here I have inside the res folder. So we're going to do res, and then car.png. I don't know how to do any other type. Also, it's going to highlight it here. If you're in IntelliJ, you'll see the car right there. But inside IntelliJ, you can see it. But make sure it's PNG. I'm not really familiar on how to do with JPEG and stuff, but I don't think you want to use JPEG because PNG does everything you need. You can have transparent background. You can have your image, high quality, right? And this try catch will usually have its own method. So let's do that. And we can just call init images. And this is just called init, is just short for initialize. You can just put it at the bottom here. Public void init images. And we have our try catch here. And here we can just add more different variables for our images. BI is just buffered image, just random name, but probably make it something relative. You can probably just make it car. Renamed car. And that was, by the way, what I just did there is refactored it. So refactored all its usages. So car is there now. But now we are able to use car. So here, instead of drawing square, we're not going to draw square. Actually, we'll keep the method, but we're going to remove this, and we're just going to do g dot draw image, and we're going to use car, and we're going to have our XY width height. Actually, it says right here, XY width height, and then an observer, which we don't have one, nor do we need one. So this will be at player X, player Y, and we're going to set it to 100 by 100. And then our image observer will be null. And it's going to be a funky looking car because it's going to be a square now. But there you go. You have your own custom image. And I talked about before an icon image here. So we can do frame.set icon image. And we can put in gamepanel.car. I think that should work out. Yeah, so if you look at the taskbar there, or in the top left of your game, you can see a little icon there, and that's your car that we just got, or whatever image you got. And boom, just like that, you have input. And like we said about mouse listener, whenever the mouse is pressed, you can do something. Usually when you have your mouse pressed, you want to check if its coordinates are somewhere. So actually, let's make a rectangle. So let's start with a rectangle. And let's just keep it there, because you're probably going to make more rectangles. And we can do rect is a new rectangle. Actually, oh, never mind. Takes too long. We'll just call it button. And we'll have it at like 300, 300, and it's going to be 100 by 100. So with this button, we want to be able to see the button. So in paint component, we're going to move this draw square. It's getting annoying. We're going to g.draw rect at button.x, button.y, button.width, and button.height. And then inside of input, we're going to check if the button is pressed. So if and we need to use button, which is an object inside of gamepanel. So what we're going to do now is we're going to get a gamepanel object, gamepanel, and we're going to have a method, because the thing is though, here we create input first, so we cannot put gamepanel in here because it hasn't even been made yet. So what we're going to do is make a method inside of input called get gamepanel. Gamepanel. And we can do this dot gamepanel is equal to gamepanel. Inside of main, after we make it, we can do input dot get gamepanel. Put in gamepanel. There we go. So now we can do gamepanel. It's gamepanel dot, and we need our button, and then we check if it contains the mouse location. The way we get that is e.getx and e.gety. Do not use e.get location on screen, or X on screen, Y on screen. That is actual your screen itself, not your X and Y, which is used for other applications. I wouldn't recommend using it. Just stick to get X, get Y. You don't really need anything else. Get point will give you a point, point object, which can be also useful. But just use X and Y. You can use get button for like right click, left click, whatever. But just keep it simple for now. So when we do that, we're going to do gamepanel dot. What are we going to do when we click it? I think that we should have a size for our car size, and it's going to be equal to 100. So down here, we're going to do car size and car size. And each time we're going to implement or increment car size by 10. And let's see what that looks like. And there we go. We have our screen here with our car. We can move our car around through the button actually, but the moment we click the button, nothing actually happens. And I'm not too sure why. I know why. It's because we need to actually add it. Frame. We may have added the key listener, but we have not added the mouse listener. So we do add mouse listener. In input, it is both a key listener and a mouse listener because it implements both. All good. FPS, always steady. Move our car around. When we click it, we can see our car gets bigger. However, you will notice something. Our car is pretty big. Is that when you click in the bottom right-hand corner, you actually won't be seeing anything. Like here I'm clicking, you can clearly see I'm clicking on the... Actually, wow, that's really clear. It's only when I get really, really perfect there, now it starts going. But down here, it does nothing. So what's going on? Well, basically, when I get my x and y, so e.getx, e.getY, it's getting it relative to our frame. However, it's not getting it relative to our actual game panel or our canvas. So here, this would not be 0, 0. This would be 0, 0 to our mouse. So this would be like you can like get the actual precise value by printing out where your e.getx and e.getY every time you click the mouse button to see the exact value and click in the corner. However, which is very useful, but usually I just go with like, what was my values? Usually you're going to have an offset. So you're going to have an int x off and y off. And it's going to be equal to some value. We can figure that out. We can figure that value out, just as I said. Whenever you click the mouse button, you're going to print out e.getx equals e.getY. And let's see what it is. When I click the top left-hand corner, you can see 9 and 31, 8 and 31. So it's going to use those values there. So our x off is -8, and our y off is going to be -31. So whenever we use it, we're actually going to have, what I usually do is have a mouse x and a mouse y. And then each time I press the mouse, I will do mouse x is equal to e.getx plus x off. And then mouse y is equal to e.getY plus y off. And when I actually use it, I'm going to use mouse x and mouse y. So then I don't have to do mouse or e.getx plus x off each time I want to use it. Probably going to use it a bunch of times. So now when I want to click the bottom right hand corner, it actually does indeed work. You can still move it around. Perfect. Sounds good. And this is essentially all the stuff that you need to make your own game. This is basically all the basics. At this point, you can go off, make your own like classes for different players or whatever. I would not typically recommend using like a player X, player Y, and whatnot. Probably just make your own entity class and whatnot. Um, you can do a whole lot of stuff, to be honest. Um, with this, um, you can kind of go wherever you want from here, but this is the basic code that I will basically reuse every single time I make a new game or something like that. I'm going to have all this code here and I have to rewrite it every single time because I'm too lazy to make a library. I probably should make a library, shouldn't I? Make it really simple. I might. I'll think about it. But until then, this is the basic code that you need. If you want to use a library or a framework on your own, like libgdx, definitely learn that. However, I think that Swing is really, really simple, easy to learn because this guy here, this is all you need. 2 lines of code and you have a window up and running. libgdx, I can't even figure out how to get it installed. It also teaches you how the update method works and teaches you the intricate details of how games actually count FPS and whatnot. And one final note to go off on is that if you were to change your FPS, let's say 60, and you want to move your car around, it's actually much slower now. And the reason being is because of your FPS change. We are updating the game and repainting it that many times. And the way games are able to, you're able to change your FPS, like in like Fortnite, for example, or Call of Duty, you're able to change your FPS. However, you're still gonna move at the same exact speed. It's because they have a new variable called UPS, which is the updates per second, and that's usually some relatively high number, not too high. Maybe for this game, maybe like 200 or something. And that's how many times it's going to update per second. And then it's going to update, so you're going to, let's say, move forward every update. And it's going to paint the same amount of times. So your speed will never change because you're updating the same amount every time. So in my other game, you saw that I had UPS there. That's exactly why. It's because if I wanted to change the FPS, I didn't like it, I could easily do that. But yeah, this is boilerplate code. You need to write every single time you want to make a game. I wish you the best. Make as many games as you can. The more times you write this down, the more you're able to understand it every time. Even now, I'll forget, like, set the previous time to the current time, or I'll forget a thing here and there, but for the most part, this is something I do on the daily, so it's pretty cool to make a game, especially an application in a new window. Just on a final note, you can't really make this into a game. So, for example, if I want to make this like an exe or something like that, you can't really do that because the way Java works. There's like methods that are really, really complicated. I'm sure there is a way to do it. However, the way Java works is that you need a Java runtime environment to run this. However, if you were to go here into build and build project, or first you need to do a couple things. You should probably watch a video on how to do that. When you turn it into a JAR or a jar file, so it will convert this entire thing into a jar file. You're able to send that jar file to your friends who also have Java installed, and they can play that game. However, if you wanted to send it to someone that does not have Java installed, then you're kind of out of luck there. But yeah, make your games. Thanks for listening.